Okay, this was fun, especially part C. Two fun conversations about this problem today. So let's see how this goes. If the triangle in each diagram below are congruent, if the triangles are congruent, state which triangle congruence condition can be used. If the triangles are not congruent or there is not enough information, state cannot be determined. Then calculate the value of x in each diagram. Okay, so let's take a look at the first one here. So as I look at this diagram, strange, mysterious. However, I do know that, wow. Boy, I would really like to know. Whoa, don't get all. I would really like to know what this angle is, right? If I knew what that angle was, I'd be way more confident in this. Oh, but wait. This is better than I thought, because it turns out, as I look at this, I've got this side that's 7 units long, and that's matched with this side that's 7 units long. So I got that side, and then I jump into this angle that's 73 degrees, and this angle that's 73 degrees, and then it turns out they share this wonderful green side down the middle. Those two triangles must be congruent by side angle side. Yeah, they share the green thing. This is congruent to itself by the reflexive property. So they have to be congruent by side angle side. Now, because of that, right? I don't need to know it. Well, I do know what that angle is now, don't I? Let me throw in the calculator. There it is. If I turn this on, whoops. If I take 180 and I take away the 28 and I subtract the 73, I get that missing angle right here, this angle right here, this has to be 70. Let me write it in this white pen. That has to equal 79 degrees. Because the three angles in a triangle have to add up to 180. Well, if I rotated that top triangle down into position over the other one, right, that is where x is going to land. So I am pretty confident in saying that the measure of angle x, or x, is 79 degrees. I almost gave up on that. Let's look at B. Ooh. Well, I do know, and I'm going to add this to the diagram, that these are vertical angles, so they have to be congruent. And because this is 23, these are congruent, and this is congruent. Oh, I'm so close to saying that these are congruent, but I do not think so. And here's the reason why. I was ready to go with angle, side, right? Because or angle, side, angle, right? But the problem is that this 9 is in the wrong spot. Or the other 9. One of the 9s is in the wrong spot. Either one of them has to be up or the other down. But if I knew that this was 9, those two triangles would be congruent by angle, side, angle. I can see it, right? This angle, this side, and then this angle. Well, if the other one, if I knew that this was 9 instead, then I could say they were congruent by angle, side, right? But I do not have that. I don't have either one of those. So I would have to say not enough info. And I'll move on to C. So C, I spent quite a bit of time looking at earlier today. And it's my understanding that in the book, they did not, on the online book, they did not include that this was 8. They didn't have that information there. That being 8 would have been, well, for a little bit of alliteration, that would have been great if that were 8. But I don't need that that's 8. but I think I might need to know what that is in order to solve for x. So this is interesting for me because I'm wanting to talk about a special right triangle, a 30, 60, 90. You don't know what that is. Why did they put this here? This is like it's someone who was working in Math 3 was writing questions for Math 1 one day. So you'll be able to do this problem soon, right? Once you know trigonometry or you know about special right triangles. But let's see how far we can get. So they are both right triangles for sure, right? And I have that one hypotenuse is 16 and the other one is 16. So I know that I have congruent hypotenuses. And I said it and I'll say it again, right? They are right triangles. So they're right triangles and their hypotenuses are congruent. So maybe, well, I don't have congruent legs, right? I got, and I wanted to say side angle side because there is that 30-degree angle, right? So I could maybe go side and then angle, but I would have to know that this side right here is exactly the same as this side, and I don't know that. And then the 30, 60, 90 pops in, right? I know because this one triangle is a 30, 60, 90 that this side right here has to be 8. From here to here has to be 8. Because that is the short leg on a 30, 60, 90 triangle. It's the leg that's across from the 30-degree angle. And it's always going to be half the length of the hypotenuse. And you're like, I have no idea what you're talking about, Mr. Roberts. And like, you're right, you do have no idea. So there is enough information here, and we could solve this right now. We could. In fact, but this question is unfair at this point. I know this is the longer leg, and that longer leg would have to be, this would have to be 3 times the square root of 8. This is 3, this is, this is 3 root 8. This is 3 times the square root of 8. So it turns out x, right, x is going to equal the whole length in blue, which is 8, minus this part up here that has to be 3 times the square root of 8. But let's look at the final one here, D. So on D, are they congruent? Let's see. Well, they definitely show us that we've got this side and this side are marked congruent. The other thing that I have is that along the bottom, this bottom, 7 plus 2 is 9, right? 7 plus 2 is 9. And then along this way, I'll do this in green, 2 plus 7 is 9. And because these are both right angles, right, because this is a right angle and this is a right angle, they're congruent. So these are actually congruent by side angle side. And okay, they're congruent by side angle side. Those are congruent triangles. Okay, those are congruent triangles. Can I figure out what x is? Man, if they were asking me, well, that would be obvious. Can I figure out what x the angle is? Without using trigonometry. Right, well actually, I couldn't here, I don't have enough information. Oh no, I have it to 5. Okay, I could figure out what x is. I don't understand this. This is the same guy as the last problem, I think. If you guys think of some way to do this using the tools from Math 1, tell me. But if this is 5, then this has to be 5 over here. And what I could say is, let's see, the tangent ratio. I could say this. I could say the tangent of angle x is equal to 9 divided by 5. Uh-huh. You're like, whatever. The tangent is the opposite over the adjacent. So it's 9 over 5. And therefore, the inverse tangent, well, if I take the inverse tangent of both sides, x would equal the inverse tangent of 9/5. So if your calculator is in degree mode, I apologize for that problem.